Hello, hello, hello. 5.6, inverse of a function. Find the inverse of a function. So first thing I want you to copy is the notes on page 277. Functions that undo each other are called inverse functions. So here's an example of a function, an equation. And when you find the inverse, you're going to switch the roles of x and y, and I'll show you how to do that. But these functions interchange the input and output values of the original function. And the domain and range are also switched. They're also interchanged. Okay. So now, what does it mean by taking an inverse of a function? So this is on page 278, top of page 278 right there. How do you take an inverse? So first, if it's written like this, f of x, it may be just a heck of a lot easier just to write it like this. Replace the f of x with a y. Like that. Make a lot easier. That's step one. Okay, do that first. Okay, then you're going to swap the places of the variables. Switch the variables. So every time I see a y, I'm going to replace it with an x, and every time I see an x, I switch with a y. So switch places. So every time I see a y, I'm going to replace it with an x. There. The x goes right there, and the y is going to go right there. Y plus 5. There you go. So now you have to solve for the value of y. So that means y is going to be in one side of the equation. Everything else goes in the other side of the equation. So remember, you're going to be doing PEMDAS. Please excuse my dear Aunt Sylvia. There you go. So remember, you're solving an equation, so you were working backwards. Can you add or subtract? Yes. Subtract 5 on both sides. And you get x minus 5 equals 3y. Okay, and now we have the y's on this side. 3 is not a y, so we have to get 3 to the other side. So that's multiply or division. Yes, we're going to, instead of multiplying by 3, we're going to do the opposite, which is divide both sides by 3. And we get x minus 5 over 3 equals y. And I'm going to write it like this. Y equals x minus 5 over 3. Normally you want, when you're done, you put y on the left side, everything else on the right. Okay. So now on question number 5, what's they're asking is they're saying, hey, solve f of x for x, then find the inputs when the output is -3. So the input is going to be your x's. Your input is going to be your x's. Your output is going to be your y values. Your output's your y values. Input, x is what you put in, and you crank it in, and when you're done, your output's a y. So if x is a -3, when f of x, when x is -3, what's y going to be? Okay. So if this is a -3, x is a -3, so instead of, whoops, sorry, x is a -3, minus 5 over 3. Well, that's going to be a -8 over 3. So -8 over 3. When x is a -3, f of -3 equals -8 over 3, or -2 2/3. Sometimes this inverse function is written like this, f of x notation. Instead of this, you can write f -1 times x. F to the power of -1 of x equals y. So that would be an inverse function. Inverse of x equals x minus 5 all over 3. Okay. Now, why is that used? sometimes in this case right here, well, what if they don't know what the output is negative 3? Let's say it's negative 12. Well, now you got to go figure out when x is negative 12. Go ahead and do that again? No. You just take the inverse of this, and now it doesn't matter what you choose. What if x is negative 52? Well, just stick a negative 52 right there, and you'll be able to figure it out. Whereas if you had this, what if that's a negative 52? You're going to have to work backwards to find the value of x. Here you've already worked backwards. Okay. Another place where inverses are used in encryption functions. Encryption functions have inverses. So a cryptic mail sent by you can be decrypted using a decrypted function. So it's used in security to encrypt things. Okay. Question number 9. Takes this thing. We want to find finds the output when find the inputs when the output is negative 3. That's going to be negative 3. So if this is negative 3, find out what that's going to be. Well, we can do that by finding the inverse. So I'm not going to do all that stuff. I'm just going to do the inverse. Replace that with the letter y. Let me back this out a bit. Make it a little easier. So we'll write it as y equals 3x to the third. Replace or switch the places of the variables. So x equals 3y to the power 3. Now we have to get everything that's, we have to solve for y. Anything that's not a y goes to the other side. Again, we're going to use PEMDAS. Okay. So first thing, add or subtract? No. Multiply or divide? Yes, we can divide both sides by 3. And now we get y to the third power. Those cancel. Equals x divided by 3. So now we have y to the third power equals x divided by 3. And how do we solve that? Can we add or subtract? No. Multiply by no. Exponents. So the opposite of raising something to the power of 3, it's going to be the 1/3 function. 1 power 1/3. So the basic thing is just cube root. So it's the cube root. So it's going to be the cube root of x over 3. The 3 times 1/3 is 1. Y to 1 is same as 1. So that's going to be your answer. And you write it like this. X over 3. So now when it asks, find the inputs when the output is negative 3. So if that's going to be negative 3, I'll put it right here. Negative 3 over 3. Negative 3 over 3 is negative 1. The third root of negative 1 is negative 1. So when the output is negative 3, the inputs are going to be negative 1. Question 15. Find the inverse of the function. Then graph the function and its inverse. So find the inverse. Okay, we've just been doing that. Finding is switch the places for the x and y. So now it looks like negative 2y plus 5. It's a negative. Now you got to leave y on this side. Make sure it's in the numerator. Y is in the numerator. Nice. So PEMDAS. Can we add or subtract? Yes, right there. Subtract 5 on both sides of the equation. We get that. Can we add or subtract anymore? Nope. This right here is negative 2 times y. And the opposite of multiplying by negative 2 is dividing both sides by negative 2. So now it looks like this. And you would write it like this, y, we're just going to switch places. We're just going to go, y goes on the other left side, and x minus 5 over 2, all that's going to go on the right side. So this would be the inverse. Sometimes it's written like this. So when you see this, this just means it's the inverse function. Okay, if that's your original function, oh, there we go. If that's the original function, then this would be the inverse function. Okay, and it says to graph. Okay, graph the function. So graph the function. So you start at the origin. So let me do start. Oops. Let me show you this. There we go. So -2 plus 5. So start at the origin, goes up 5 units. It's going to go right through that spot. That's 5. 1, 2, 3, 4, 5. Then from that spot, it's going to go down 2 units. 1, 2, right 1. It's going to go to that point. Down 2, right 1. Down 1, 2, right 1. 2, right 1. Down 2, right 1. Okay. So that's the original function. So I get, boom, that. Now your inverse function is always going to be, so you have to think of this line right here. So this is just a chord. This chord is the equation y equals x. So it's always y equals x always goes through that origin. It's just a diagonal line going through the origin. That line right there, this line right here is y equals x. So if x is 5, y has a value of 5. If x is 12, y has a value of 12. So I'm going to take that line right there. If you take that line, y equals x, that's what it looks like. And the inverse is just going to be a mirror image of this line right here. So there's the inverse. So this green line is the actual equation itself, and this is the inverse. So it should look like a mirror image. This one right here, if you took it and you just reflected it on this side of the line, it'd be a mirror image. So these right here should be a mirror image. It's kind of like a butterfly effect. Okay. So you have that. What if you had an equation like this? Oh, hold on. One thing I have to tell you that we know how to find when you have a graph. If actually it is a function, you do the vertical line test. So here's a vertical line, straight up and down. If this vertical line only touches that function at one point, what if I go here? It's only touching at 1 point, 1 point, 1 point, 1 point. So that is a function. Okay? That means if it's a function, when you take the inverse, that means you will be able to have an inverse. Now, when you take the inverse, how do you know if you're going to have an inverse function if it's also a function? Okay, if you have this right here, if you took this now, this is the inverse. This would be a horizontal line test. The inverse of a function is also a function only if it passes the horizontal line test. A horizontal line should only go through this at 1 point. So right now it only touches at 1 point, right there. Any horizontal line at any point, it's a horizontal line test. Okay. If this inverse does this, that means it would be a function when you go back and had the original equation. Okay, so let's do this. What if you have this equation right here? That right there, that's the original equation. Does it pass the vertical line test? Yes, that means it is a function. So you will be able to find an inverse out of it. And the inverse is always going to be a reflection about that line. And it looks like that. It looks like a mirror image of each other. It's always a mirror image based on this line. This line is the equation y equals x. Let me do some more. Here's a weird equation. It's a weird looking equation. That's the original line. Does it pass? Is it a function? Yes, it passes the vertical line test. So when you do the inverse, looks like that. Notice how these are just reflections across the line y equals x. Okay. Some people say it's a butterfly effect. Sure, if you want, if that helps you. So this inverse should pass the horizontal line test. This only touches the graph at only 1 point. 1 point, 1 point, 1 point. Anytime I do that. Okay. What if you have an equation like this? Is that going to be, oh, no. See right now? Let me try it again so it doesn't. There we go. Now it touches there and there. Let me get that line out of the way. That line right there, it touches right there and right there, so it's not a function. What if I move it over here? Oh, here's another place. Right there and right there. It's not a function. Okay. If you did the inverse relative to that line, oh, it already is. That's an inverse of itself. So the inverse, would it pass horizontal line test? Nope. Since it did not pass the vertical line test as a function, that means it won't pass the horizontal line test as an inverse. Okay. That's the equation for a circle, by the way. We've done that in Algebra 1. We did that in geometry. Hopefully you remember that. Okay. Now here's a weird looking thing. What the heck? Does it pass the vertical? No, it doesn't. What? It doesn't pass the vertical line test because it right there goes through it. The vertical line touches it twice. Right here it touches it more than once. 1, 2. Right here it touches it more than once. 1, 2. Okay, so it's not a function. So if you took the inverse, okay, that's the inverse. Well, where's the y equals x line? There you go. They're just mirror images of each other. So does this would be the inverse, but it doesn't pass the horizontal line test. So you cannot get it inverse. It would not exist. Okay, so keep that in mind. Keep that in mind. So the horizontal line test, what I want you to do in your notebooks, put this in your notebooks on page 278. The inverse of a function is also a function if and only if no horizontal line intersects the graph of f more than once. So this only hits it more than once, no matter where you put that horizontal line. The horizontal line, no matter what you do, it's only going to hit that line once. In this case, here it hits that this horizontal line intersects that curve more than once. Right there, it happens right there, happens right there. So it only has to happen, right, happens at that point right there. The horizontal line touches it more than once, therefore that inverse is not going to be a function. Okay, it would not work. Okay, we get over here. Number 53. Number 53. 53. The word problem. The word problem. The maximum hull speed v in knots of a boat with a displacement hull, blah, 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 blah. Here's the equation. V equals 1.34 times the square root of L. V is the speed in knots, the velocity in knots. L is the length, the waterline length in feet of the boat. Find the inverse of the function. So inverse of the function. Okay, switch to two variables. So we have square root v. Okay, and now we have to take v and leave v on one side. Anything that's not a v gets the other side. So divide both sides by 1.34. Now we have square root of v equals 1.34. We want to find that by itself, so this is the square root. Opposite of a square root is squared. So v equals So I'm going to write it like this instead. L 1.3. So there's your inverse. What's the water length? What water line length is needed to achieve a maximum speed of 7.5 knots? So if this is 7.5 knots, what's L going to be? Well, I'm just going to use this right here. And remember, we switched it here, so I'm going to switch this back. So if the velocity is 7.5 knots, then use a calculator. Use a calculator. 7.5 divided by 1.34. That quantity squared. You get 31.3265. 31.3265, and that is in feet. Go to 2 places past the decimal. 31.33 feet. So approximately 31.33 feet. And that's it. The water line is that, according to this equation, the water line is 31.33 feet. The velocity will be 7.5 knots. Or, sorry, wrong way. If the maximum speed is 7.5 knots, what's the water line length going to be? 31.33 feet. Okay, there you go. Good luck, guys. Bye-bye.